Hello, and welcome to Calculus1 4.3 Graphing Functions.
Very good. So, hello and welcome back to Calculus 3. Calculus 1, oh my god, 4. Yeah, it's Saturday. Okay, it's fine. It's Saturday. Happy day, right? Everyone loves weekends, so we gathered here such large numbers to enjoy calculus.
To mourn the death of my calculus grade.
Mourn the death of your calculus exam grade? All right. The service will be held after the lecture. So today we learn how to graph functions without graphing utility. Yes, in today's day and age, you are supposed to install a free app on your cell phone and retire your graphing calculator because it's a single-purpose device, right? You can find free apps. All of you received the email with a $1,000 gift, right, in it, and hopefully some of you already cashed in, which is great. Use it to check every problem that you do, not just this course, but also physics, chemistry, bio, so on. And use it definitely to check these. So I will show how to use software now that I have this new machine with software installed. We are going to graph functions now. We're going to use pretty much everything you ever learned in mathematics, starting from addition all the way up to last class, which was first and second derivative tests. Hope you reviewed all of that stuff. These problems are long because you have to compute a lot of stuff, and then you put all of that together and just graph works somehow. Let's see. So we all know how y equals x squared plus 3 looks like. You can all graph this without any issues. But let's use calculus to graph this and see what we can do to graph functions, because the ultimate goal is to take a look at let's say ln of absolute sine squared x and graph that without any issues. So these are kind of things that you would be able to do once you know how to deal with this. The procedure is kind of straightforward. There is a shopping list of about 10 to 13 things that you can calculate about this, and then you just put that information together on a graph and it works. So let's start. This is a very easy problem. So domain is from negative infinity to positive infinity. We know that that's the domain for all polynomials. Range, really can't compute the range in here. So we'll just leave the range alone for now. But I can definitely compute x and y intercepts. So X-intercept is when we set y equal to 0. So 0 is equal to x cubed, x squared, plus 3. From where we get that x squared is equal to negative 3. So no real solutions. And we need the real solutions on the x-axis, which means no x-intercept. So no x-intercept. For y-intercept, we set x equal to 0, so y is equal to 0 squared plus 3, which is equal to 3. And we do have a y-intercept. It's a point, so we have to go 0, 3. So domain, range, x-intercept, y-intercept, you are already 4 calculations in, right? Well, we didn't do the range in this case. Some cases you can easily. The next calculation that we are going to do, again, it's we're moving now from algebra into pre-calculus from pre-calculus into calculus, it's asymptotes. So you have those definitions for asymptotes for vertical, horizontal, and you know the slant occurs only when you have polynomials. This is x squared polynomial. Polynomials do not have asymptotes. So no vertical asymptote, no horizontal asymptote, and no slant asymptote. We are already 7 calculations in. The next part is to calculate the first derivative. So y prime is equal to 2x, from where we can do the first derivative test and obtain min, max, and all of that. So let's go with the critical points first. 2x equal to 0, from where I get x equals to 0, and when I plug into original equation, I get 0, 3. Now 0, 3 is either a min or a max or inflection point, and we'll cross off the list once we get there. So now we're going to do the first derivative test, and since we only have 1 point to worry about and we only have a 0 to worry about, no vertical asymptotes for further partitioning. This is what we learned last time. We are going to pick 2 test points, -1 and +1, let's say, and we are going to do the first derivative test. So first derivative computed at -1 is going to be 2 times -1, which is -2. We see that the function is decreasing on that end because it's less than 0. And the first derivative computed at 1 is 2 times 1, which is 2, larger than 0. So the arrow goes up. In this case, we see visually, right? I'm going to draw that this is kind of behavior that we are getting, which means that the point 0 is a minimum, which is how we cross these guys off, and we know that 0, 3 is a minimum. All right, so now we move to the second derivative. Y double prime is equal to 2. Now you set 2 equal to 0, has no solution, which means no inflection points, right? No inflection points, because we couldn't solve that equation. 2 is not the same as 0, so And then immediately we do second derivative test. Now we have nothing to partition with, so everything is one partition. From -infinity to +infinity, we do not have any important points like vertical asymptotes or deflection points. Therefore, we have everything as one partition. You can pick any number to be your test point, but there is no need. You already see that the second derivative is always 2, which means your second derivative, f double prime of any value x, is always equal to 2, which is always bigger than 0, which means that you have concave up on the entire domain. Concave up on the entire domain. So now, here my fingers, I'm going to do counting. We have domain, range, X-intercept, Y-intercept. We have vertical asymptote. We have horizontal asymptote. We have slant asymptote. We have first derivative with critical points. We have the first derivative test, which also tells us min and max. We have the second derivative with inflection points, and we have the second derivative test, right? So that's 11 calculations that we already did to find stuff. Now, additional calculations could also be thinking about even and odd functions, where we can actually check if this function is even or odd by utilizing those formulas that if the function exhibits this property, it's even, which in this case is true. If the function exhibits this property when you plug everything in, it's odd, in which case this is not happening. So you can do that. And then as if you are getting really stuck, some parts are a little bit tricky, or you don't have enough information, you can compute additional points. By simply plugging in random values. Let's say you are fairly sure what's happening with a function, let's say between -infinity and +7, but you're not sure really what's happening after 7. So you plug in numbers 8 and 10 and just, see, because we generally graph, from negative 10 to 10. It shouldn't be restricted to that because a lot of application problems call for much wider domains. But, can do it. All right, so now we are going to put all of this information on the graph. So we draw x and y axes, and we put everything that we know. So far, I know that there is number 3 there, and it's a minimum, so I'm going to put a smiley face through it. There are no X-intercepts, which means this will never well, actually, you can just use the decrease on the left and the increase on the right, and the whole thing needs to be concave up. So it's just a parabola going. You knew this. It was just interesting to see how and why. This is why I say if you're tutoring, someone in high school and they say why, there you go, right? Give them this explanation for $60. Yeah, it will take an hour, right? So yeah, so that's that. But we are generally interested in, cooler stuff than this. How about, some functions that are divided? Maybe we can throw in some ln's, some e's, things that we generally, run to calculators and software to graph. Obviously, this is very inefficient, right? But if you are on a desert island, right, and the batteries ran out, the Wilson is gone, you have nothing else to do, obviously, right, the obvious choice. You do 2 or 3 of these problems and you're rescued by the time. That's how it goes. All right, so let's see another function. How about, I don't know, ln x squared divided by 3x. All right. So function is, yes. So ln of x squared divided by 3x minus 1. All right, fine. So this is the function. I have no clue how it's going to work out, but it will work out because it has to. The first is the domain. So the first issue is the domain. We know that ln x has domain 0 to infinity, with 0 not being included. So now this, I think, preserves the domain because the vertical, it has a double vertical, nice. Beautiful. Beautiful. I know. Okay, because it's a -1. If it was a +1 on the bottom, it would be a different story, but okay, cool. This is really cool. So what do we know? We know that we cannot compute ln of 0. We can't compute ln on infinity either. So when we are going to have an issue here when you have x equals 0, because it would be 0 divided by -1, which is 0. So domain still starts at 0 because of x squared on top, right? That's going to be 0 divided by -1, which is 0. ln of 0 is -infinity. So we don't have, right? You have to know default state. You have to know this. That's what you have to know. So this is what I consider common knowledge. We are trying to graph something much more interesting. So because x squared over 3x minus 1 is 0 when the numerator is 0, then that means the domain starts at 0. Now, looking at the denominator, we're going to have an issue at 1/3, right? 1/3 is going to give us 0 in denominator, and when we have 1/9 divided by 0, well, that explodes, right? So at that point, we have to cut at 1/3, and then union 1/3 to infinity, because all other values are fine, I hope, right? X can be any positive value in denominator. You can have 1/2. You can have, yeah, everything else works. Great. So that's the domain. Range, you can say negative infinity to positive infinity because you know how ln looks like in general. You also know it has a vertical asymptote. But, you know, let's keep the range again. Let's go for x-intercepts right away. We'll set y equal to 0, which means ln of x squared divided by 3x minus 1 is equal to 0. How do we solve this? Very good. So we get x squared over 3x minus 1 equals to e to the 0 is 1, which gives us, when we cross multiply, x squared is equal to 3x minus 1, and then that gives us x squared minus 3x plus 1 equals to 0. Now, since we picked, you know, any values out there, right? Right, Eli? This is not factorable, but you can always use the equation, right? Negative b plus minus square root of b squared minus 4ac and suffer through that. So negative b, that's going to be 3 plus minus square root of 9 minus 4ac would just be a 4 over 2. So at least it works as 3 plus minus root 5 over 2. So we do have x-intercepts. Root 5 is 2.23, so 3, 5, 7, so about 2.5 and negative 1. Those are the values. But, you know, we have x-intercepts. So I have two x-intercepts, 3 plus root 5 over 2, 0, and 3 minus root 5 over 2, comma, 0. Now, I will put their approximate values on the side because we will have to plot this, right? So, as I said, 2.23, so that's 5.23, so about 2.6. That's all I need. About 2.60 for the first one, and the second one is going to be 2.3, so that's about 0.8, so about negative 0.4. Good enough. So we have two x-intercepts. To find y-intercepts, we are going to set x equal to 0. But we know that doesn't happen, right? So no y-intercept because you can't have ln of 0, right? ln of 0 is negative infinity. So no y-intercepts. Vertical asymptote. Well, we already discovered two vertical asymptotes. We know that there is a vertical asymptote x equals 0 because that's what the ln gave us, right? Well, let me do this. Let me do the whole proof for it, so that way we know. So, since ln x has vertical asymptote at x equals 0, the function ln x squared over 3x minus 1 will have vertical asymptote at x squared over 3x minus 1 equal to 0, because you see that that's the argument, right? The argument of x was equal to 0. So again, argument of ln x is equal to 0. So that's the same calculation technically. All right, so we got that part. And that calculation gives us, right, that calculation gives us 0. So we have the vertical asymptote as x equals to 0. Now we also have another vertical asymptote, sorry, it's not a vertical asymptote, right? what's happening with the other one? ln of infinity is infinity, so that's just that's gonna be so weird. Yeah, we'll see. So do we have another vertical asymptote? The answer is no. That's the only one we have. Horizontal asymptote. ln does not have horizontal asymptotes, and no slant asymptote, right? Because it's not polynomial divided by polynomial, also known as rational function. So now what's left is to take all these derivatives, check out critical points, get min, max, the increase, decrease, and then inflection points in the second derivative. So, you know, standard stuff. So what's the first derivative? F prime equal to. So it's ln, right? So because we have ln, it's immediately division line. We put the argument as is, and its derivative in the numerator, but that's a quotient rule, right? So we have 3x minus 1 squared, 3x minus 1 times 2x minus x squared times 3. Fast to simplify this, the square kills this one, and we have what? We have the numerator is x squared, no, numerator is 6x squared minus 2x minus 3x squared divided by denominator is x squared times 3x minus 1. 1 stays, right? Only squared cancel. So the first derivative is equal to 3x squared. I'm going to factor out x. So 3x minus 2. And denominator is x squared 3x minus 1. And now this one of these x's cancels. Awesome. And now we need to know when this thing has, right, when this thing is 0, which is when we are going to have min-max. But we also have to know when it does not exist, because at those points you also might have, right, min-max. So what we have here now is equation 3x minus 2 over x times 3x minus 1 equals to 0. When you cross multiply, you simply get 3x minus 2 equal to 0. So x equals 2/3. So 2/3 is a critical point. Well, we'll find the y value for the point, right, x comma y. But we also see that it does not exist, right? First derivative, f prime, does not exist for values x equals 0 and x equals 1/3. Now, those are standard issue points that we had from before. Now, we know that x equals 0 is a vertical asymptote, and we are still not sure what the hell this is. Well, we'll figure it out, but we don't know what 1/3 is. Because 1/3 gives you, when you plug in 1/3, it gives you the ln of infinity, which is infinity, right? Cool. Next thing. So we have a critical point. Now we can find the y value by simply plugging in 2/3 in original function, right? Original function was what? ln something. So to find the y value, it's f of 2/3. So that's equal to what? Y is equal to ln of x squared, which means 4/9 divided by 3 times 4/9 minus 1. Yeah. So that's 12 minus 9 is 3. ln of 4/3. So we have a critical point. at, so we have a critical point at 2/3, comma, ln of 4/3, which you can obviously figure out the decimals for. It's gonna be about 0.3 or something like that. If my ln skills are still there. Let's see.
0.287.
0.287. So yeah, I was 2 cents off. That's bad. .28. Well, I'm gonna call it 0.3 because I'm actually doing everything 1 decimal. I complicate. That's exactly what.
Yeah, sure.
What are you gonna do? You know, such is life. All right. Whew. So now it's time for us to do the first derivative test. We have a critical point. We have all the weird points that are going on, so we have enough for partitioning. First derivative test, f dt. Now our partition starts at 0 because there is nothing left of 0, right? It's ln. Well, there's nothing in a real plane. Yes, on Wednesday we're gonna uncover some stuff. It's gonna be epic. So there's nothing left of 0, so that's where the partition starts. We also said there is the weird stuff happening at 1/3, and then there's the weird stuff happening at 2/3. That's the critical point, and then that's it, right? Then it goes all the way to infinity. So I have to come up with 3 test points. So, you know, you pick anything, I guess 1/6, and 1/2, and 1. So those are the values we test. So first derivative computed at 1/6. Where's our first derivative? So it's 3 times 1/6 minus 2 divided by 1/6 times 3 times 1/6 minus 1. These guys cancel. I get -3/2 on top, right? Because it's 1/2 minus 2. On the bottom, these guys cancel, so that's a -1/2. So it's a -1/12. So now these guys cancel as a 6, and I get positive value, so increase. Right? Negative divided by negative. I don't care what number do I get. It's a positive number. I just move on right away. Now we plug in 1/2. So we have 3 times 1/2 minus 2 divided by 1/2 times 3 times 1/2 minus 1. Numerator is 3/2, so this is -1/2. No, yes. Good. And then 3/2 minus 1, 1/2, 1/4. So that's negative. I don't care the value. So it appears that we have some kind of a maximum at 1/3. Great. And then we have, so there's a max there. Right, the point does not exist, but it's a max. I know. The derivative at the point, sorry. The derivative at the point does not exist. We have those cases. Never forget. Square root of x. Sorry, the absolute x, right? Derivative at the peak does not exist, right? But it's a minimum. That's why we have the critical point definition to be what it is. Now 1, plug that in. 3 times 1 minus 2 divided by 1 times 3 times 1 minus 1. So that 3 times 1 is 3 is 1 divided by 2. Larger than 0. So increase again, and we have a min over here. Awesome. But wait, for this 1/3, how the hell are we gonna compute the? You can't compute the y value. We got that it's a maximum. That's really weird. I have to see how this looks like actually. All right, second derivative. F double prime of x. What was the first derivative? It was 3x minus 2 divided by x 3x minus 1, right? Oh, logarithmic differentiation, right? That's what the logarithmic differentiation is for. So 3x minus 2 divided by x over 3x minus 1 times the logarithmic differentiation here gives us 3 over 3x minus 2 minus 1 over x. No. Yes. And then minus 3 over 3x minus 1. So that's the second derivative in factored form using a logarithmic differentiation. And to set this equal to 0, we get again x equals 2/3, right? That's bad. I should not be getting the same point to be a minimum n inflection. That makes no sense. Eli, you made this problem extra spicy. Concavity. So this point cannot be min or max. Max? Min, right? But I'm getting, from this term, I'm getting the 2/3 is inflection. And then we have 3x minus 2 minus 1 over x minus 3 over 3x minus 1 equal to 0. You do the algebra here. It's x, 3x minus 2, 3x minus 1. And then you cross multiply all of it, get the numerator, and then that numerator only is equal to 0. So that's what? 9x squared. So 9x squared minus 9x. This one is, oh holy nightmare, that's a 9x squared minus 9x squared minus 3x minus 6x minus 9x plus 2. So plus, no, minus 9x squared plus 9x minus 2. And then the last one is minus 9x squared, 9x squared, and then minus minus give me plus, so plus 6x. Okay. So these two drop, but I still have negative 9x squared, minus 9x plus 9x, they drop, but I still have plus 6x, and I have minus 2. Why did I get minus 2? Oh, when I fall I get 1, okay. Minus 2 equal to 0, and this is the one that you have to factor, so you can just multiply by negative 1. And we have our negative b plus minus square root of 36 minus 4 times AC, 4 times 36, 72, and there you go, complex. So the second part does not give us inflection points at all. All right, so far we have this one inflection point on 2/3, which I don't really like, but that's what we have. It's a 0 and the 2/3 and infinity. So we are going to pick test points, maybe 1/2 and 1. Those are the good test points, and check those. So if this is a 2/3 inflection point, then concavity must change, right? One side we have to have concave up and concave down, right? So let's see. The second derivative, computed at 1/2. Now, where's my second derivative? There it is, already regretting it. Didn't we already compute this thing at 1/2? And we got negative, right? So it's negative number times, and I just need to compute the parenthesis. So 3 over negative 1/2, that's a negative 6. When I plug in 1/2 in the parenthesis there, it becomes -2. And when I plug in a half on the last one, 3/2 minus 1. So it's going to be still a minus a number, I don't care what. It's negative times negative is positive. So concave up. I don't care what the values are. You can go and compute. We said at 1 is 1/2, so that's okay. I can write this one 1/2 and then compute the rest at 1. That's 3 over 1, so that's 3 minus 1 minus 3/2. That's 1/2 times 3 minus 1 is 2. See? Still positive. So concave up. So it's not an inflection point. It's not an inflection point. And we had it was a minimum before, so wow, what a evil problem. Great. Now let's see if we can, oops, that's not problem done. Let's see if we can graph. If not, we'll find more points and stuff. So I start with my xy. I know there is a vertical asymptote at 0. And I know that the function prior to that was increasing. Oh wait, I know what my I forgot to do this, guys. Look at this. I forgot to cross this one out. Not in the domain. I gotta kick that one out. So I have about 2.6 as an important value. 2.6 and then 1/3 and 2/3. One-third, 2/3, 1, 2. 2.6 is almost there. Okay, cool. So 2.6 is the X-intercept. So we put the point there. Then we have something. What do we have? Critical something. What do we compute? ln of 4/3. So 0.3. 2/3, 0.3 minimum. I don't like this graph at all, because oh no, it's decreasing. Yeah, so it goes from here, right? Goes like this, and then well, see, we did not detect the other concavity, but looks like it's gonna do something like this, right? Because it has to be nope. That's bad. I know up to this point, right? It goes like this. I know it has to cross, and because it's concave up and it goes increasing on this end, has to do this. Now I did not detect another X-intercept for this to cross below. This problem is all bad. This is what happened when we just pulled the random problem. Let's see. Wait, why is this not? Video output low. That's probably the network is not pulling enough bandwidth. Come on. This is how your $1,000 gift looks like. When you... No, you're doing the 30 frames per second. I'm not sure why that's saying. Alright. So once you install Mathematica, make sure you install this with your school email, because that's how you get the free license. Otherwise you have to pay $1,000. This is what you get. You will see just this. That's Mathematica. And then you click on a little plus here, and you can use Wolfram Alpha Query because it will give you nice formatting, but that only works if you are connected to the internet. And I'm thinking this is now bugging out because of the too much bandwidth used by streaming. I don't know. Try it again.
Can we just say that that problem was just a segue into how to use Wolfram Alpha?
Nah. So graph ln open parenthesis x squared divided by open another parenthesis 3x minus 1 close two parentheses. There it is. That's our problem. Now Mathematica uses log as ln. That's how it looks like. The top one. And we ignore the red. Yeah, that's why we didn't detect.
That makes sense.
But I got the decreasing. Oh no, it is increasing.
Yeah.
Wait, did I draw?
Yeah, you when you were graphing it, you did it negative.
Ah, I drew the... Yeah. So it is like this.
Yeah.
Okay.
I was gonna say something, but I have too much faith in it.
Aww. So yeah, so that's the cusp there, and then it goes like this, but it shows that it goes through x-axis there, and it doesn't. What is this value here? We did not detect that value. Oh no, that's a one. Yeah, that's this one. Okay. So it's a really evil problem. All right, well let's use the textbook examples, I guess, which will be far easier.
That's why we can't have nice things.
Oh, we can have nice things.
Can't have Eli given to you.
Eli give it to you. All right, great. So there are okay, two cusps here, so it goes like that. Now this goes up to infinity, and they connect, and it goes to the one that we detected. Wow. All right. Your lab examples are going to be much nicer than this one. Let's see what nicer examples can we get. As long as you remember the shopping list of 13 things to do, you're, I guess, good to go. All right, textbook in 10 seconds. And we want to pick a problem. Because usually what they do is they find problems, they construct problems so that when you find all those derivatives inside, it falls on whole numbers and it's easier to graph and all of that stuff. So let's see. Here we go. Chapter 4, 4.4, and then we go back one. So don't have so many beautiful ones, but all right, so let's start now again. Let's do at least 3 of these. We'll start with the simple one, I guess, 18. It says f of x is equal to 2x minus 3 over 2x minus 8. It looks simple, right? Let's see if it is simple. Domain, polynomial divided by polynomial, so anything that it's not giving us 0 in denominator. What's giving us 0 in denominator? 4, right? So we go negative infinity to 4, union 4 to infinity. Range for these guys is negative infinity to positive infinity. The vertical asymptote is going to follow it. X-intercept right away, which is y equals to 0. So that's just 2x minus 3 equal to 0, which is x equals to 3/2. So we have the x-intercept at 3/2, 0. And the y-intercept, which is x equal to 0, which is negative 3 over 8, right? Negative 3 over negative 8. So we have the y-intercept at 0 and 3/8 when you plug your x's to be 0. Then we have the vertical asymptote. The vertical asymptote is at 4. You can do the limit to prove that. Horizontal asymptote is where? Horizontal asymptote is 1. How about slant asymptote? You can't have horizontal and slant at the same time. Awesome. All right, so we beasted through the first stuff. Now we'll go with the first derivative. The first derivative, you can use logarithmic, or you can use your quotient rule. Let's use quotient rule because we can. It's not too crazy. So 2x minus 8 squared, 2x minus 8 times 2 minus the top, so 2x minus 3 times 2. So I have 4x minus 16 minus 4x plus 6. This over here, this smudge is 3 clearly. Divided by 2x minus 8 squared. These guys die over here. I have negative 10 over 2x minus 8 squared. And if you want to set this first derivative equal to 0, you have no solution because negative 10 is not the same as 0. So no crit points. But you can still partition because there is a vertical asymptote. Or even if there is no vertical asymptotes, then the whole thing is one partition and the function is always increasing or decreasing. So that's fine as well. So vertical asymptote is the only partition that we have for our first derivative test from last time. So the first derivative test we have from negative infinity to positive infinity, which is domain, and we are partitioning that at 4. So I'm gonna pick 0 naturally, and then maybe number 5 because everything else is equally evil. First derivative computed at 0 is negative 10 divided by a positive number. I don't even care what that value is because it's squared. You square anything, it's positive, right? So negative divided by positive is negative. So we have a decrease on this side. F prime at 5 is going to be negative 10 divided by, again, positive value. So there we go. So it's always decreasing. And again, you can have this behavior. Just think of 1 over x, which is always increasing, right? And you still have a vertical asymptote. Cool. So we have no min, no max. Let's take a look at the second derivative. Now, I would urge you not to use quotient rule here, because this is simply negative 10, 2x minus 8 to the negative 2. So we just use basic chain rule to solve this, which is 20, 2x minus 8 to the negative 1 times the derivative of the inside. So it's 40 divided by 2x minus 8. So for the derivative, that's what we do. And to set this equal to 0, again, no solution, which means that we don't have inflection points. But you still have to partition over the vertical asymptote, because as you can see, vertical asymptote x equals 4 is preserved. Remember that derivatives preserve vertical asymptotes, whatever they happen. So our second derivative test has the same partitioning as first. We go from negative infinity, make a stop at 4, go to positive infinity, and we pick same values, I don't care, 0 and 5, whatever. Now that will change, as you can see. So second derivative at 0 is 40 divided by negative 8, which is negative 5, which is less than 0, which is concave down. And at 5, we have 40 divided by 10 minus 2 is 20, larger than 0, concave up. All right. So now to graph this, what do I have? Let's go. I have vertical asymptote. I'm going to make this graph larger. Vertical asymptote at positive 4. Horizontal asymptote at 1. And then y-intercept at 3/8. 3/8 is right here. I have no min, no max. I have concave down, concave up, and then everything is decreasing. Now remember, concave up, concave down, decrease, decreasing, decreasing. If you draw the pieces for concave up, this piece breaks into two pieces that look like this. Which one of these two pieces, when you break the concave up part, is decreasing? Yes, so the left one, right? So he said the middle one, and I said so the left one, right? We used all of the words. So what we have here is that this concave up piece breaks into these two pieces, and the left one is the one that corresponds to concave up and decrease. Concave down piece breaks into two pieces that look like this, and decreasing part would be that one. So these are the two pieces that I have to use to fit. So what it says, it has to be concave down first and decreasing, has to follow the asymptote at infinity, go through our point, What? I just gave up. Why? Do you see that I'm getting X-Intercept? But then we say there's no X-Intercept. What's going on? Was there a full moon or something?
We said there was an X-intercept.
There is?
Yeah. Over and three.
Oh, 3 half.
Up zero.
We definitely need. I need a therapy session now. Thank you very much. That 3 halves is right here. There we go. Because these things have to fit, guys. So it goes through one, goes through the other, and then bends down to follow the asymptote, and there's the graph. At least I can graph x squared. Good thing I don't have to do any of the exams.
Fill me with confidence.
I know, you're better than me. It's clear. Next problem, something interesting and nice. What I failed miserably at? I failed miserably at ln, so what do? We do another one. This is in a textbook, problem 22. So we did 18, now 22. Let's do it. Eli is enjoying this, sitting up there like a boss, smiling as I cry. Domain. Well, we have to be very careful with this domain. We know that the basic ln x has the domain to the right of the y-axis, right? But there is an issue here, and the issue is called the x squared. What happens is you plug in 3 to x squared, right? It becomes ln 4, so it's cool. But when you put a negative 3, it's still 4, right? So now the ln x has the domain like this, but ln x squared has the domain that looks like this, because both values are allowed, positive and negative. All right, so now we have to worry about that. First of all, let's see, is 0 okay for the domain now? If x is equal to 0, right, it's okay. 0 is okay, because ln of 0 plus 1 is ln of 1, which is 0. So 0 is okay value. How about 1? 1 squared is 1 plus 1 is 2 ln 2. That works. So what value does not work? Everything works, right? You say negative 1 doesn't work? Well, it does. When you square it, you get 2, so it's ln 2. It seems that every single value works. We just fix it. So negative infinity to positive infinity. This being ln range should be a quick negative infinity to infinity as well. Or is it? No, it's not. It doesn't have horizontal. The range is going to be 0 to infinity, but I don't want to ruin that for you. Because I believe that this graph is going to look like this. I think that's how graph's going to look like. And that's a 0. Right there. That's how I think a graph looks like without doing it. But let's do. So I'm going to put the question mark there. Steph, you pull something nice from your emojis and put it there, right? Nah. As you're creating the piece of art. X-Intercept. Well, X-Intercept is when the argument of ln is equal to 1, right? Because ln of 1, so because ln of 1 is equal to 0, right? We need x squared plus 1 to be 1, which happens when x squared is equal to 0, x equal to 0. So we have 0, 0, x-intercept. Y-intercept is when we set x equal to 0, so y equals ln of 0 squared plus 1, which is ln 1, which is 0. So we have the same 0, 0. Right? When 0, 0 is 1, it has to be the other as well, because that's what x and y in axis meet. Cool. We got a forced 4 done. So how about a vertical asymptote now? No. We don't have a vertical asymptote because we can't make argument 0. Right? You have the vertical asymptote. So here, because we need x squared plus 1 to be equal to 0. But you can't get that with real numbers. You can get that with I on a complex plane. So vertical asymptote is nope. How about horizontal asymptote? No, right? Why? Let's say you have a kid that's asking why. Limit of ln of x squared plus 1 as x goes to infinity is infinity, right? So it's not a finite value. You know how to prove limits, so there you go. That's a proof. And slant asymptote is obviously no, because it's not one of the rational functions, polynomial divided by polynomial. So we got the first 7 calculations out of the way. It's time for calculus, finally. First derivative of x is equal to, so that was ln, which means put the x squared plus 1 down and this one, set it equal to 0, 2x equals 0, x equals 0. So we have a critical point, right, at 0, 0. So that's min, max, or inflection. First derivative test. We know that we are on the infinite domain, right? So we have to go from negative infinity to positive infinity. And we have to partition at 0 only. We have no vertical asymptotes. So let's just use negative 1 and positive 1 because we can. First derivative computed at negative 1 is negative 2 divided by a positive, right? You have x squared, that's always going to be positive, and you plus 1. So that's less than 0. We have a decrease. And then first derivative computed at 1 is 2 divided by a positive number, which is larger than 0. And we know that now this one is a minimum. Excellent. Time to take the second derivative. Second derivative is going to be, we have x squared plus 1, everything squared, and then x squared plus 1 times the derivative of the top is 2, minus 2x, the derivative of the bottom is 2x. Awesome. So that's going to be 2x squared plus 2 minus 4x squared divided by x squared plus 1, everything squared, which is, you can factor out 2, right, when you simplify that, and you get 1 minus x squared divided by x squared plus 1, everything squared. See, that's beautiful. Because as you set it up to 0 to find inflection points, you just have the numerator. It's okay, you can laugh. There we go. Take it out, get it out of the system, because now you can focus. We setting things equal to 0 over here. So cross multiply, we have 2, 1 minus x, 1 plus x, when you factor everything, equal to 0. So 2 is equal to 0, 1 minus x equal to 0 where x is 1, and 1 plus x equal to 0 when x is negative 1. Now obviously this does not give us any solution. 2 equals 0, right? So we have two inflection points now, which is 1 ln 2 and negative 1 ln 2. Partitioning for the second derivative test from negative infinity to positive infinity is done. We have negative 1 and 1 as the important points, and then we find the values in between. So we can use, I guess, negative 2, 0, and 2. All right. So second derivative, maybe I should label these inflection points. So now second derivative computed at negative 2 is going to be 2 times 3 divided by positive number, so larger than 0, concave up. Second derivative computed at 0 is 2 divided by 1, which is again positive, concave up. I don't like it. And at positive 2 we have again, now that's a negative number there. Well, it was a negative before as well. Negative 2 squared is 4. This is negative 3. So that's less than. That's why I didn't like it. Concave down. Awesome. And another concave down. It's symmetric. Divided by a positive value, right? So less than 0. Concave down. Okay, I have all the ingredients I need to do the graph, I hope. There's a point 0, 0. And then I have the concavity at 1 and negative 1. So what do I have? I have that the graph is concave up in the middle. ln 2 is about 0.7. So we're going to do this. Now it's gonna go forever, so you don't have an asymptote, right? Because that goes up and to the right and left and up forever. So we have our inflection points where the U shape concave up changes into a concave down part. And we see that the decrease happened up to 0. and increase, right? That fits as well from our calculation. Questions, concerns? All right, so I'm at 50% efficiency now. Got 100% on the first, 100% on the last, almost nothing on the second, and most of the credit for the third, right? All right, cool. Let's do one more for me to fix my average, you know. There's one group of functions that you love and we did not discuss at all. Well, that's kind of Alan.
Yeah.
Which one? Which functions? A whole group of functions you studied. Trig, your favorite. Exactly. We have choices over here. They give us lots of beautiful choices between tangent inverse and 2 cosine x and e to the minus t sine. See, we can marry the e with sine.
Tangent problems.
X plus tangent x or inverse tangent of x squared.
X plus tangent x.
X plus tangent x. All right.
Seems relatively simple compared to the inverse one. I said relatively.
All right.
Wait, what was the function? Inverse.
The inverse tangent of x squared. All right, so I'll let you do this for about, 10 minutes is good?
Yeah.
So try on your own to go through the entire list. Maybe I should put the list on the board. So this way you know what's in the shopping list. Domain, range, X-Intercept, Y-Intercept, vertical asymptote, horizontal asymptote, slant asymptote, first derivative equal to 0, first derivative test, second derivative equal to 0, second derivative test, extra points, even odd, we rarely use it, and then finally graph at the end. Don't panic for the exam, because the way I write the exams is I break this problem over 4. I ask you to just do a first derivative test, and then completely different problem for the second derivative test, completely different problem for min and max stuff and inflection, and then I have a problem which gives you all of the information in the chart, and you just need to draw the graph. So technically, imagine that I did all of this work. All of this is done by me, and I provide you all of this information in one chart, and you are supposed to just look at that chart and come up with a graph. So that's how exam format is for the next time. I'm not a fan of asking you to do this 45-minute long problem, because obviously, if you mess up on the first derivative, then everything else is wrong after that, which includes.
It's be annoying to grade because, if I mess with the first derivative, but everything else is correct based off the messed up derivative, they should still get
Yeah,
points.
but it's just still wrong. It's actually very easy to grade.
Depends how nice you want
Wrong
to
graph. X. 0. Move on.
be. Wrong color pen.
That too. Right? People solve theirs and pink or something.
For blue, man.
I'll go back to high school, red pen. The color people use the grade.
Yeah, I actually use red most of the time. It's just that I just didn't want to get out.
So I have a friend that's a student teacher right now, and they're making grade in green or blue because it's not as aggressive a color as red, so it won't feel as bad.
It's not a real thing, right?
It's a real thing. And anytime a kid says retarded, you're supposed to admonish them for it. I think it's a Hamilton. I think.
It's becoming more like that. More and more like that at universities.
At university?
Yeah, aka
I
Hamilton.
thought this was like middle school.
No.
He's a student teacher for middle school.
Okay.
Oh, okay.
But university is becoming more and more like that.
Dude, if I was a professor, I would be like the meanest professor.
What's the world coming to? You can't make horrible racist and sexist jokes anymore. Yeah. Like I could get like being offended if they were told with you or whatever, but if it's off in the corner, you're not involved in the situation.
I thought that was a myth, and then I went to the business coalition. Oh, they were chill about it, right? It was still innocent. Yeah.
That's the problem. Why don't we just find it in one and monster?
There's the president over.
I hope you are already at the second derivative.
Of course.
It's too busy bullshitting you.
I mean, who wouldn't be?
Yeah, I think I have one.
What?
I have one.
It's just kind of early, right? Like, it's 12:10, it is 11:07 past 12:10.
You know, I don't think he keeps attendance and everything is recorded. You just go and eat lunch and come back if you felt like it.
Now it's done.
I've been tempted to do that before.
See, I'm trying to maximize my scholastic pursuits, so I gave up sleeping and eating. So,
Is there any inefficient?
no distractions.
Is that in the second derivative?
Yes.
Good. Okay.
They need the do not like button.
No, apparently that's too aggressive.
That's a thing when people, some people want to
Just no.
I've never got the whole posting your entire life on Facebook.
Dude,
Like
I
you
don't
think
do that. I just watch everybody else do it now.
your genetics are messed up, I'm sorry. You shouldn't have
are you that narcissistic? You think everybody wants to see your shit?
There's gonna be $1 for road run fundraising, by the way.
I wish I was there for an unlimited display job.
Like I should donate like $20 by now, and that's the only time you ever called me on it. crack a window. Like bro, sweater anything.
Terrible thing.
I own it. Yeah, they're big.
Okay. There's the worst word you've ever seen that ChatGPT. Like it needs to be modded for the online
Does it
version.
have controller support?
It does have to do.
Oh, I can use a controller then.
But when the online doesn't work, when you need a mod to make it work, that's when you might be able to. But I mean, it's still a fun game. Yeah. And they have Watchdog that like if someone is hacking and tries to invade you, and that means that you can be screwed and drive by because it's the